The goal for offense is to score runs. So when it comes to scoring runs, what matters most for a team? Batting average, on base percentage, slugging percentage, or OPS, which is on base plus slugging. So that's what we're going to investigate in this video. The first thing I want to do is create runs per game. So I created this column here. I simply took the number of runs a team scored in the season and I divided it by the games played. So for most teams, games played is 162, but there are a couple of teams in the data, here the Tigers and White Sox, who played only 161 games. And you can see here from this data set, the Tigers were the worst offensive team in Major League Baseball last year, only scoring on average 3.6 runs per game, 3.61 runs per game. So there are a couple ways we could go about doing this. The first way is we're going to just run a simple linear regression where our dependent variable is runs per game and our independent variable will be average. And then we'll run another regression by changing the independent variable to on base percentage, and then a third regression where our independent variable is slugging percentage, and likewise a fourth regression where our independent variable is OPS, on base plus slugging. Okay, so let's first do this by doing a simple linear regression by regressing runs per game on batting average. So we're going to go to data analysis. There it is. We're going to select regression. We're going to put in our input Y range. That's our dependent variable, so runs per game. I'm going to just highlight that with my mouse. The input X range will be the average column, batting average column. That is our independent or explanatory variable. Since I highlighted the variable name, I will select labels. I need to put this output somewhere, so I'll select the output range and I'll put it right here, and then I'll hit OK. So we're familiar with this output from regression in Excel. Our constant term, our coefficient on batting average, we can see the T-stats and so on. What I want to concentrate on here, however, is the R squared. So that's the coefficient of determination. And if we were to take the square root of that, we have a measure of the strength of the correlation between runs per game and batting average. So a correlation coefficient can range from -1 to 1, and in this case we have a correlation of roughly 0.78. Okay, so that's giving us a strength of this relationship, linear relationship between runs per game and batting average. The question is, could we get a stronger relationship by using another offensive variable? So how about if we look at it with the on-base percentage? So let's run a regression, another regression. But this time change the independent variable to on-base percentage. Put our output somewhere over here. Hit OK. Get our results, and once again let's concentrate on the R squared. We have a much higher R squared here than before, so our correlation between the two variables is going to be much greater. So our correlation coefficient here is 0.93. There is a much stronger linear relationship between on-base percentage and runs per game than batting average. So if you're building a team and you're looking at trying to score the most runs per game, you would put emphasis on on-base percentage over the batting average. Batting average pales in comparison to the on-base percentage. Is this the best one? Well, you can discover that for yourself by running a couple more regressions, using the slugging percentage as the independent variable, and then OPS. One other thing I wanted to point out, if you wanted to, you could do this analysis by creating a scatter plot, and I did that with, or I will do that with on-base percentage and runs per game. So just going down here, I'm going to insert a scatter plot. So we got runs per game on the y-axis and the on-base percentage for the team on the x-axis. I'm going to right-click on one of these observations. I'm going to add a trend line. This is just our regression line. And we're going to display the equation on the chart and the r-squared. Move that around. There you go. And just taking the square root of the r-squared to get the linear coefficient, or the correlation coefficient. It's what we saw before from the regression output. So a fairly strong linear correlation between on-base percentage and runs per game. A lot stronger than what we found with the batting average. All right, I'm going to stop here. Hope you found this video helpful.